Hi, everybody. Welcome to this webinar. I'm here with Emma from BASF, and she's going to tell us all about metal filaments. Recently, we were at CMTS, a trade show here in Toronto, Ontario, where we had a lot of great questions about this metal filament that BASF has for us for FFF printing. And to get into that, I want to bring in Emma, who will introduce herself shortly, to talk a lot more about this very specialized filament. Emma, how are you?
Doing great, Ken. Thanks for having me. How about
Awesome.
you?
Fantastic. So thanks for joining me today. I wanted to talk to you and have you introduce yourself, who you are, what you do, and also where you're located.
Yeah, sounds good. So, hi everyone. I'm Emma Corey, and I am the Applications and Technology Specialist for our filament product line at BASF. So, I know that's a lot of words. So, really, what I do is I work with our end customers, our distributors like Shop 3D, machine manufacturers, really on any technical project we have for our Ultrafuse filaments. And I am located at our Application Technology Center in Detroit, Michigan.
Amazing. And we're focusing on this metal filament today, but tell us a little bit about BASF Forward AM and what you guys do, and in terms of your whole portfolio.
Yeah, absolutely. So at BASF Forward AM, we are the 3D printing group within BASF, which is a really big chemical company, if you're not familiar. Um, and so BASF Forward AM was established in 2017. Our headquarters are in Heidelberg, Germany, but now we have locations in the US and Asia as well. Um, yeah, so we have three product lines. We have powders, resins, and filaments. As I said, I'm responsible for our filament product line, and within that, we have your standard materials that you would use: PLA, ABS. We also have other engineering grade filaments, such as like some flame retardant options. We have glass fiber and carbon fiber filled materials. We also have TPUs, support materials, and as Ken mentioned, that what we're talking about today are our metal filaments.
Yeah, at Shop 3D, we carry BASF almost all of those filaments, and we love it because it has such a wide engineering range of capabilities. You can pretty much find a filament, tailored to your application, from the entire portfolio. But of course, today we're going to be talking about one of the ones that we're most excited about, which is metal. Before we get into metal, maybe I'll just start from the very beginning. But,
Sure.
can you give me a brief rundown of what metal filament is and what kind of printers we can use with this filament?
Absolutely. So, um, for the ultrafuse metal filaments, it's a metal powder combined with a polymer binder system. So that polymer is what allows you to actually extrude this material, melt it down. It's not just, a bunch of metal powder, a lot harder to process. Um, for our metal filaments, they can be used on pretty much any open FFF system, which is really convenient, makes it really accessible. Um, and in our traditional BASF business, we have what is called the CAD product line. So this is a metal injection molding process, and our ultrafuse metal filaments are all based on our traditional CAD mold technology. So really pulling in a lot of that know-how to then create metal filaments exclusively for 3D printing.
Yeah, and this is definitely, a first in the industry and one that really lowers the barrier to entry to printing with metal filaments because as Emma said, you can use printers like the Ultimaker back here, or you can use Raise 3D, BCN 3D, names that we carry to print this filament. Whereas previously, you would need a much more expensive, much more intense system to do metal 3D printing. So this has really lowered the barrier to entry. And I think we're going to see some amazing results from this, but I think you have two types of metal filament. You have 17-4PH and 316L stainless. Maybe you could talk a little bit about the differences between the two and why you have two different options.
Sure. So, yeah, as Ken mentioned, we have two different metal filaments. For 17-4PH, the biggest advantage there is really enhanced mechanical properties. It's a very common industrial stainless steel, good mechanical properties, and you can heat treat this metal for even better mechanical properties. When it comes to 316L, it has really good corrosion resistance, and it also is good in high temperature or more humid environments. So those are the big differentiators when you're looking at choosing one over the other. If you're really looking more for the mechanical properties, go for 17-4. And if you need that more specialized, corrosion resistance or humid environment, then go for 316L.
And what would be great examples of some simple applications, for each of those materials?
Yeah, so for both materials, they can be used for customized tooling, jigs and fixtures, of course, prototyping. These can also be really good for replacement parts. Maybe you have that, super old part in your warehouse that maybe you broke or you'd like to have a backup, and yeah, there's just not, maybe getting a new one is really, really expensive, but you could 3D print it instead, and you just need one that makes the cost much cheaper. And they're also great for small series production. So again, if you want to manufacture maybe 100 parts versus 100,000, metal 3D printing is a great place to go for that.
I think one of the things I forgot to address is
Mhm.
sometimes people think metal filament is kind of like the aesthetic metal filament where you have some copper powder inside a PLA and it looks metal, but you're not going to get an essentially metal part. That's not what we're talking about right here, right?
No, so this is a true metal filament. So I know we're going to get into this, but when you finish the full process of printing and going through debinding and sintering, you end up with a fully 100% metal part. So a lot of people ask me questions like, is it metal? Is it fully metal? Yes, it is.
Yeah, and just to prove the point, I have a couple of metal pieces here, and just listen to this. That's gonna tell you it's pure metal all the way through, and it's as strong as it sounds. So it's a pure metal print after we get it and have it processed. But before I get into the processing, let's talk a little bit about the workflow. I think a lot of people are very interested about how they can go from getting a printer and this filament to coming out with a metal piece. But can we start at the very beginning and talk a little bit about printing it on the printer? Do you have some best practices? Are there anything special that you need in order to print this filament?
Yeah, so for printing a metal filament, I know a lot of people think it seems really daunting, but if you are out there and you're printing a carbon fiber filled material, you can print a metal filament as well. So what I mean by that is, you know, we mentioned already, you don't need a dedicated system, really high temperatures. You can print it on your Ultimaker that Ken has sitting behind him. But what you do need is a hardened nozzle, which again, same thing that you would need for other fiber-filled materials, and some adhesive. So we generally recommend Dymafix or Magigoo 316L. That is their specific metal adhesive for our materials. Put that down on your bed and you should be ready to go. And you may think I missed a step, which is drying your filament, but with metal, you actually don't need to dry it, which is
Wow,
another very convenient aspect.
that's fantastic. I mean, a lot of people worry about that when they're printing, with the fiber materials like nylon, it absorbs a lot of moisture. So it's very good to know. In terms of actual printing, what about settings and preparation? Do they need to do anything, in their slicer to prepare for metal printing?
So to prepare for slicing your part, the main thing to know is that your part will shrink as it goes through that debinding and sintering process. So when you're slicing, you need to scale that part up. In the X and Y direction, we recommend scaling to 119%, and in the Z direction to 125%.
Okay. Now that's interesting because why would there be more shrinkage on the z-axis? I guess it's not more shrinkage, maybe it's just gravity.
It is exactly gravity.
Okay.
Yep. And so that's definitely something we always want to keep in mind with debinding and sintering is, even in the shrinkage, you see the effect that gravity can have on a part. Um, and, if you design really complicated things, gravity will also affect those. So always good to keep that in mind.
Yeah, I think we'll get a lot into that with the debinding process, but good to know about the shrinkage rates. In terms of handling the printed parts, so I actually have a green part that we've printed here, a brake lever, and eventually it's going to get sintered into this part. But what are some of the things and good practices that we should have when preparing a green part before we go through the debinding and sintering process?
Yeah, absolutely. So, one thing that I get asked a lot is, when your part is printed and it's on the build plate, it can be really hard to get off the build plate. So something I like to note before even, you know, getting to our green part is you want to, in order to get the part successfully off the build plate without cracking the part or anything like that, if you just soak either the build plate or pour some water on the part. It will actually dissolve the adhesive and make it really easy to get your part off. So, yes, definitely insider tip makes life much easier when removing those parts. And then when you get to your green part, um, things to keep in mind are you really want to make sure that bottom surface of your part is flat so you can sand it down to make it flat. With that in mind, you can also sand the edges of your part.
Okay.
Um, if you had maybe like one little part that was over extruded, your green part's actually pretty fragile. You could either cut it with a blade or sand it down. So you can really do some nice processing in the green state to get a really nice looking final part. You can even bead blast to get rid of some of those layer lines. So yeah, working with your part in the green state can really improve the final part.
That's actually a really good note because sometimes you have little bits of filament sticking out. You should definitely cut that off, clean that all up while it's in the green state. Can you polish it a little bit to make it a little bit smoother before we go into the debinding process?
Yeah, so really the main ways that I would do that are sanding or bead blasting, and it really cleans up that surface nicely.
Okay. And you mentioned that it was kind of fragile. So, this
Mhm.
part is not a finished metal part. So, I can't treat this like a metal part. If I drop this now, I could break it. Is that correct?
Yes, exactly. So even though we are going to get to our really strong, durable metal part, right now this is actually pretty fragile. Um, so yeah, definitely take care with it, and yeah, just something to keep in mind.
Okay, great. So eventually it's going to get into a metal part. So maybe what I can talk about right now is a little bit about shrinkage and also maybe using a raft or some of the design, specifications and recommendations that you might have to producing a more successful print. Because I think, to me, I feel like the process going from the green part to the sintered part, is one where, first of all, we don't handle, but that's kind of the riskiest part, right? Where the part can kind of fall apart during that process. What are some things that we can do to make sure that we have the best success possible?
Absolutely. So starting with your green part, um, really important since you do have to ship this part elsewhere to have the debinding and sintering process taken care of. When you ship it, make sure it is wrapped in bubble wrap. We like to say, make sure your package passes the shake test.
Mhm.
If you are shaking your box and you can hear all your parts moving around, more bubble wrap. You can never go
Right.
wrong with more bubble wrap. So really take good care of your parts so they don't break in shipping. But what you also really need to look out for is designing for debinding and sintering. So, like I said, if you're printing other filled materials, you can print metal, but what you really need to keep in mind, and the big difference is some of the design constraints.
So
So,
what is that what we're talking
mhm,
about? Are we talking about handling support or are we talking about overhangs?
um, kind of all the above and in between. So, Um, yeah, so one thing to really know is the size limitation. Kind of a good like quick and easy reference is about the size of your fist. That's about the ideal size part that we want to print for metal. So if someone has this huge part they're looking to print, it might not be successful or the right application for metal 3D printing. Um, we talked about you need to scale up to size. And then other things to keep in mind, you don't want a really, really tall, skinny part because that could fail in debinding and sintering. It might just collapse under its own weight. So making sure we have a optimal height to width ratio, ideally not exceeding 3 to 1. Um, Also, we don't want really tall, skinny, thin walls either. Um, some of those really small features might be a little too fragile to survive the process. Um, and yeah, kind of I think you already mentioned the shrinkage plate. So that one is a really powerful tool and something that can help get geometries that maybe we couldn't have processed before without them warping.
I see. So what about overhangs? How do we handle overhangs and support?
Yes, so depending on what your overhang or where the support is needed, it's possible to print overhangs with metal support. So basically, you're self-supporting. With that, though, your metal will survive through the debinding and sintering process. It'll be supported all the way through, but that means you would need to machine those supports off. So if you have those capabilities in-house or easy access, great. That's, just really adds on to the possibilities of what you can do. Um, but also an option is printing a separate support. So maybe like if you had an overhang, maybe printing like essentially the inverse of your part separately from the actual part. And then something really helpful that they can do when you send your part for debinding and sintering is spray a ceramic coating on that support. So that keeps your support and part from fusing together, but you're still able to support your part throughout the whole process.
Yeah, so I guess that's safe to say that if you were doing very complicated parts like that, either with thin walls, or tall structures or large prints, and with support, that almost gets to another level of difficulty that you kind of want to work yourself up to,
Mhm.
from printing metal. Is that correct?
Yeah, I would agree. I generally, when people are starting out, I like to tell them, start with something is going to work just to get a feel for the process. I think that alone can really just give you a better understanding and then start getting into those more complex geometries.
Fantastic. So it sounds pretty simple so far. We print, our green part. We can follow a design guide. I think that there's one provided by BASF on, what's best practices and what we should kind of follow in terms of design. So after we do all that and we have our successful green part, what happens next? How do we get this into metal?
So we actually don't handle processing the green parts here in my lab, or can you in your lab. We actually partner with DSH Technologies. They are located in New Jersey and they service all of our North American customers. So that includes all the Shop 3D customers as well. Um,
Yes, so we actually
yeah.
make a coupon available to purchase on our website where you can buy 1 kilogram of sintering for your metal filament. I think it's only $60 Canadian, which is extremely affordable for the work that they're doing in debinding and sintering. So maybe I'm going to let you talk about what that process is like, actually.
Sure. So, like I said, basically you will ship your green part to DSH, and they are the experts in this process. So, that really takes a lot of the, expertise away from us, and just, you can rest assured that your parts are in the hands of experts. Um, but what they're going to do is put the parts through catalytic debinding. And what that does is it basically uses acid to eat away at all of that polymer binder that is in the metal filament. After that, when you have no more polymer binder, we call it a brown part. Um, this part also has the consistency of like wet sand. So that's really where these design considerations that we were talking about come into play, because you need your part to survive in a wet sand consistency. After it's in the brown part phase, the part will then go to a sintering furnace and the metal particles will all be sintered together. And this is where that shrinkage occurs because there's a lot of open space now that all the polymer is gone, so your part will shrink down. After this, you have your full metal part and it will get sent back to you and you're good to go.
That actually sounds way simpler than it is because you can just ship it off and then it comes back and, a full metal, part. But you talked about how, DSH were experts at metallurgy, and I can absolutely confirm this. We've had some calls with them where they just blew us away in terms of what they know about metal and processing. I mean, we had to ask a couple times just to understand all the stuff that they know in terms of processing this material. So they're extremely specialized in it, and thank goodness it only costs us $60 to get this done because I know someone's going to ask, but can someone do this themselves?
So, in theory, yes, you can, but that requires some very expensive equipment, very specialized equipment, and a lot of safety considerations. So, one of those safety considerations is working with nitric acid or hydrogen gas. So you're probably putting this in a manufacturing or industrial facility. Again, very expensive. And like we said, you need a lot of expertise to operate this equipment. So, yes, it is possible, but, you're not just putting that in your like small office or small lab. Like it takes a lot. So generally we say best to leave it to DSH and the experts.
Yeah, and I think that makes a lot of sense. From an ROI perspective, the cost is so minimal to give it to these experts to do. It almost doesn't make sense to do it yourself unless you were doing mounds of metal, on your own every day, every week, and have a workflow for it. So that makes a lot of sense to us in terms of letting DSH handle it. And we've had some fantastic results. Everything we've done through DSH, and it's been very, very successful. The parts that are not successful, what usually happens so that when we get it back apart and it's not exactly what we expect, for example, like it's warped in a weird way or there's
Mhm.
some cracks in the metal, why does that happen when we do get a fail, let's say?
Sure. So, yeah, I guess one of the first things you said was warping. So a lot of times we'll see warpage. Maybe it's a more unique shape or, you know, a longer part, but a shrinkage plate can really help with a lot of that. And a shrinkage plate is basically just a separate plate from your part, and it's very, very dense, printed with, very highly filled, but it's just a metal plate that you can put underneath your part. And you basically make sure it surrounds the entirety of your part. But when it's going through that sintering process, as it's shrinking down, everything will shrink at the same rate. There won't be as much friction on just if your part was resting on, the typical plates that aren't moving. Everything can shrink in a uniform way, and that really helps with warpage. The other really important thing that I like to point out to people is that the part that you send in, the bottom needs to be super flat, like completely flat all the way across. If you tap your finger on it and something's lifting up, you're likely going to have a problem. And that's where, if you put an uneven part through the debinding process, again, we said it's like wet sand and gravity's going to win. So basically, that part will just drop back down and you'll have a crack in your part at the end. So that's really where we see the biggest fails.
Yeah, I think we have to emphasize that during the sintering process, it's going to through thousands of degrees of heat, of expansion and shrinkage, in order to get sintered together. So all that stress will translate into defects if you didn't follow the design guide, or if you're trying to, or if your print is uneven. And early on in our journey for printing metal, we did have a couple of applications engineers who want to push the envelope. Hey, what if we do it just beyond recommended guidelines. What if we made it here? What if we don't support it? And we had some epic fails, and that's on us, of course. But we wanted to test to one confirm your suspicions and our suspicions that those design guides are really useful and necessary, but also to see what a fail would look like. And actually, some of those fails look really awesome too, because it does get sintered together. So it looks like this cool metal part that just collapsed in on itself. I don't recommend that because you're, sending in a part that is going to fail, probably cause some trouble for DSH. But I think following the design guide is extremely important, and having the recommendations that you have of sanding it and making sure it's flat. So now that we have our print back, what can we do with this? I mean, this is the finish that it comes back with. It's kind of like a matte, metal finish. You can still see a little bit of layer lines from your printer. It still does show up. But is there any way for us to post-process this even further?
Yes, absolutely. So, like I emphasized before, this is 100% metal. So, anything you might do with a traditional metal part, you can do with a printed part. So, if you wanted to get rid of the layer lines, you could polish your part. It also makes the part look really, really nice. Um, let's say you had some critical features that you would prefer to machine versus print. You could machine this part, get it to the exact specifications you needed. Um, you could weld the part. So really, really, the options are really endless. Anything you can do with a metal part, you can do with our printed metal.
Amazing. And I actually have a great example of that here. So we have our standard sintered part, and then we have the polished part, which is very shiny metal. still all metal. And I think the tolerance that you were talking about is very correct. Where if you wanted to make sure that this was the perfect tolerance to fit into your other part, then you can just machine out, this particular section, and that's probably a little bit easier than trying to predict the shrinkage all the way through for an internal shape. Is that correct?
Yeah, if you have those really critical features, I think, yeah, machining is always, it's a really just a good addition to metal printing. I think using those two tools in combination can open up a lot of part geometries and possibilities that maybe weren't possible with just one technique over the other.
And I think that's still in a lot of ways, cheaper, faster than traditionally just CNCing out a metal part, especially for certain geometries. This is going to make a lot more sense, especially if it's for a one-off or two-off.
Yes, exactly. I agree.
So I think that's covered, the whole process of getting from your filament all the way to a steel part and even polished and finished up. But I definitely have some frequently asked questions if I could throw these your way.
Absolutely. Let's hear them.
First one is, uh, how do the parts compare to extruded metal? Because that's one question that I got quite a lot at CMTS, and they were like, "Well, it feels like metal. How does it compare to other forms of metal manufacturing?"
Yeah. So, when comparing 17-4, printed metal to our traditional Catamold 17-4, it's actually very comparable. This is still a printed part, so with polymer printed parts, you're going to have weaker mechanical properties in the Z direction or whichever way your layer lines are going. And we do still see that with metal prints as well, but overall the mechanical properties are very comparable to their traditional metal counterparts. And one thing I like to point out is that we actually have the mechanical data for our printed parts and the Catamold extruded part or metal injection molded parts in our TDS. So really quick, easy reference for you.
Yeah, I think BASF has some of the best TDSs we've ever seen on the planet. If you want to know all about their filaments, all the technical details, it is available on the TDS. Much more than just what we're saying now. You can get actual numbers and values, and you guys are very, very serious when you do your testing for that.
Absolutely. We are a traditional chemical company, so we definitely take all those documentations and testing seriously.
Exactly. And I think it's on, just as a comparison, it's on a completely different level than just a 3D printing company because they're used to just 3D printed materials, whereas BASF is doing real materials that are used all over the world in all different stages. One other question that comes up often is, once it is sintered, is it a 100% metal part?
So yes, it is a full metal part. There's none of that polymer remaining. So yeah, it is fully metal.
And the polymer that we use as the binder, what is that polymer?
So it is a POM, POM.
Okay. So that's the binder material that we're burning out with the catalytic debinding.
Yep.
Fantastic. Okay, so that covers a bunch of questions that I have that's been asked of me. Could we talk a little bit about where someone can find more information on doing this themselves if they're interested?
Yeah, absolutely. So there's a lot of documentation both on the Shop 3D website and the BASF Forward AM website. You can find the TDSs that we were talking about, process guidelines that we're talking about, and even more documentation than that.
Okay, fantastic. So you can actually get this filament at shop3d.ca over our website in our stores. You can talk to one of our account managers if you want some design guide ideas or questions that we can answer for you. We also carry the DSHD binding coupons so that you have the complete workflow of going through from printing all the way to sintering. One last thing I wanted to end with, and that's, I think we're going to have a special promo for some of the viewers of this webinar. Um, Emma, do you know what that deal is?
Yes, I do. So if you are attending and watching this webinar and you want to purchase some of the metal filament from Shop 3D, we're going to offer a 10% discount for those viewers. So we really want to encourage you guys to test this out, get your hands on the material.
Yeah, absolutely. So I'll put a link or a overlay of what that coupon code would be so that you can access that exclusive coupon to get a 10% off. And I gotta say, 10% is really generous, considering, what you're getting and how much money you're saving to make metal prints already. So I thank you for everybody for joining us today. Thank you, Emma, so much for your time, your knowledge, and sharing with us, all the nitty-gritty details of going from a print all the way to a metal part. It was way easier than I expected. I think people think it's very daunting to begin with, but you really don't need any special equipment. You really just need the filament, some design guide know-how, and then just follow the process, which has been well laid out for us to get your parts printed. So I want to thank you for your time today, and I want to thank all those for joining us. If you want to get your coupon code, make sure you enter it in, go to the shops3d.ca website and purchase your metal filament. Again, we're also here to help if you have any questions about the filament. So thank you, Emma.
Thank you, Ken. I appreciate you having me. You're always great to work with and partner with. And yeah, I just want to reiterate to everyone, if you have questions prior to metal printing, talk to Ken and his team at Shop 3D. They are so knowledgeable, so helpful. And yeah, they are just another tool to help you succeed with metal printing. So thank you all for attending.
Thanks so much, Emma. And if you guys want to see more from Emma, more explanations on different filaments, we also have some reels on our website where Emma talks about a lot of the different areas of portfolios that they have, TPUs, polypropylenes, and she goes through some of the details of those filaments. So not just metal, Emma knows a lot about plastics. So Emma, I want to thank you again for joining me and taking the time for this webinar. And I want to wish you have a great, happy weekend.
Thanks, Ken. You too. I appreciate it.
Okay. Bye-bye.
Bye.
All right, 15 seconds.
All right.
Hey, we're back with a live Q&A with Emma and myself, Ken. So thank you for joining us for that webinar. I hope you've enjoyed all the technical details that were there within the webinar. And I think we answered a lot of questions that were submitted to us in advance. So thank you for that, Emma.
Of course.
I wanted to bring you back so that we can talk a little bit about some of the questions that were submitted. And I want to get to some of the user questions that they've asked. I know some of them might seem like they were already answered, but maybe we can just reiterate on some of those topics if that's okay with you.
Absolutely. Let's do it. Happy to answer any questions.
Fantastic. Great. Okay, so the first question I have is, can I use the Bamboo X1C to print this filament?
So we don't have a validated profile on the Bamboo printer, but it does meet the technical requirements in terms of temperature and any other print parameters. So it is possible. We just don't have that validated profile yet.
Yeah, that sounds good. And you know what? We actually have an X1 here as well. It's one of the printers that we resell. We haven't tested the metal filament on it either at this point, but we don't see why it can't be done. So at this point, it's a highly likely maybe. I would say that if I were to make a quick recommendation, it would be the X1E because that enterprise version does have a heated chamber, which is going to make it a little bit more consistent for heat while printing the filament. So that's probably what I would recommend. But if you already have an X1C, I think giving it a try is probably a good idea. So the second question I have, Emma, is there are several metallic filaments on the market. Will BASF develop metals other than stainless steel?
So we always are working on new things in our pipeline. Our R&D team is, actively working on new products. I can't give any specific updates on, the exact products we're working on or timelines yet, but yeah, it is definitely something we hope to have in the future. My recommendation is always to reach out to the team at Shop 3D or us at BASF and tell us what you're interested in, and then that helps us focus our efforts as well.
Fantastic answer. I think that's great. I mean, obviously we don't really announce things before they're ready, but BASF is a very innovative company in this space, so I'm sure there's a lot of stuff going on there. Thank you for that answer. Next question I have is, what kind of ventilation is recommended?
So if your printer has an air filter on it, that definitely can handle any off-gassing fumes that would be released while extruding this temperature or while extruding this filament. What we do recommend, though, is to print this within the recommended temperatures that we have listed on our TDS. If you're printing significantly higher, there may be other testing that needs to be done, but if you don't have an air manager, air filter on your printer, just adequate ventilation, a larger room that isn't super stuffy, and you should be good.
Yeah, I think we always talk to people about, if they don't have a filter. So a lot of our printers already have filters like Ultimaker S5, S7, and the Race 3D series. But if you don't, it's all about concentration. If you're doing it in a small little closet, that's not going to be good for you if you're sitting in that closet as well. But if you're doing it in a large office, it probably just dilutes, into that large space without any trouble.
Exactly.
Great. So a few questions I have are based around, printer printer recommendations. So I might get to those in a bunch, but for now I have someone asking if processing of the parts, are available if there's any partners in Ontario or Quebec.
So unfortunately right now, the only official partner that we have that does debinding and sintering in North America is located in New Jersey, DSH Technologies, as we mentioned. I know that can be a bit more inconvenient shipping internationally, but I know Shop 3D does a great job working with their customers to make that process as seamless as possible. But we also recommend, if people know of a metal injection molding place that can handle this type of processing, you are welcome to find somewhere, but just in terms of official partners, not anywhere in that location, unfortunately.
Yeah, I think that's something that we were looking for as well, since we're located in Canada, but DSH are the experts in this space, and they've absolutely produced great parts for us every time we sent it over. The next question I have, Emma, for you is, can we use this filament with the FunMat Pro 410 printer? It's pretty specific, so I'm not sure if you know this or have this in your lab.
I do not personally have it in my lab, but again, it's a printer that, just based on printer processing conditions and the requirements for this material, it should work. Again, we just don't have that validated profile. But again, similar to the bamboo, I don't see why it wouldn't work.
Fantastic. The next one I think is a question for me. It says, what is the price of the product for 17-4PH? So I can pull that up. So it comes in two versions. You can get it in a 1 kilogram, or you can get it in a 3 kilogram. The 1 kilogram version is $199 Canadian, and then the 3 kilogram version is $485 Canadian. So pretty darn affordable metal filament for the purpose. So the next question I have is, if I have access to a programmable kiln that can fire up to 2,500 degrees Fahrenheit, can I sinter or fire this material myself?
So I will say we do have all of the debinding and sintering processing requirements on our website, on our product pages. So if you need to see the specifics, we do have it there. But I will say On top of just a sintering furnace, we have to go through a debinding process, and that is catalytic debinding. It requires nitric acid. It requires a second piece of specialized equipment. So you would need both of those things in order to do this in-house.
Yes, I think they're thinking about just the last step of that process, but post-processing actually has those two steps where we need to do catalytic debinding as well. So thank you for that answer. Secondly, how reliable are most parts printed with this product compared to CNC machined parts?
So, I think they're asking about tolerances here. Is that my guess, Ken?
A little bit about tolerance and I guess about strength as well.
Okay. Yeah. So, in terms of strength and mechanical properties, one thing that's really nice about our TDS is they actually show at least a metal injection molded part of the same feedstock. So 17-4 feedstock, 17-4 printed, they'll show that comparison of mechanical properties, which is really nice.